From January to April, the global surface temperature rose 2.41 degrees Fahrenheit over the baseline of 54.7 degrees Fahrenheit, making it the warmest year since record-keeping began 175 years ago. According to NCEI statistics, 2024 has a 61% chance of becoming the warmest year on record, with a 100% likelihood that it will be one of the 5 warmest years. Given our concern about temperature, which is one of the long-term effects of climate change, let us look at climate change from a broad viewpoint. Climate change is a term used to describe global warming, the continual rise in global average temperature, and its consequences for the Earth's climate system. Climate change, in a larger sense, refers to prior long-term changes in Earth's climate. Since the Industrial Revolution, human consumption of fossil fuels has been the primary cause of the present rise in the world average temperature. Fossil fuel consumption, deforestation, and some agricultural and industrial practices all contribute to greenhouse gas emissions. These gases absorb some of the heat that the Earth emits after it warms from sunlight, thereby warming the lower atmosphere. Carbon dioxide, the principal greenhouse gas responsible for global warming, has increased by almost 50% and is currently at levels unparalleled in millions of years. Climate change has a growing environmental impact. Desertification is on the rise, and heat waves and wildfires are becoming more common. Increased warming in the Arctic has contributed to permafrost thawing, glacier retreat, and sea ice loss. Higher temperatures cause more severe storms, droughts, and other weather extremes. Rapid environmental change in mountains, coral reefs, and the Arctic is forcing many species to move or become extinct. Even if attempts to reduce future warming succeed, some consequences will last for centuries. These include ocean warming, acidification, and sea level rise. Climate change threatens humans with greater flooding, harsh heat, food and water scarcity, sickness, and economic loss. Human migration and conflict can have serious implications. According to the World Health Organization, climate change is the most serious threat to world health in the 21st century. If no action is taken to reduce global warming, societies and ecosystems will be at greater risk. Adapting to climate change through initiatives such as flood management or drought-resistant crops helps to reduce climate change risks, although some adaptation limits have already been met. Poorer communities contribute only a small part of global emissions, but they have the least ability to adapt and are most vulnerable to climate change. Many climate change effects have been felt in recent years, with 2023 being the warmest year on record at plus 2.66 degrees Fahrenheit since regular recording began in 1850. Additional warming will amplify these impacts and may result in tipping points, such as the complete melting of the Greenland ice sheet. The 2015 Paris Agreement pledged nations to keep global warming well under 35.6 degrees Fahrenheit. However, even with the agreement's pledges, global warming is projected to reach 4.9 degrees Fahrenheit by the end of the century. To keep global warming at 34.7 degrees Fahrenheit, emissions must be cut in half by 2030 and zero by 2050. Energy conservation and the transition to low-carbon energy sources can help phase out the use of fossil fuels. Wind, solar, hydro, and nuclear power are among the various energy sources. Clean electricity can replace fossil fuels in transportation, heating, and industrial activities. Carbon can also be taken from the atmosphere by increasing forest cover and adopting farming practices that collect carbon in the soil. Humans evolved throughout the last few million years during the ice ages, when temperatures fluctuated between 33.8 degrees Fahrenheit higher and 41 degrees Fahrenheit lower than today. The last glacial maximum took place 20,000 years ago, when sea levels were 410 feet lower than they are today. Since the Industrial Revolution, the seas have absorbed more than 90% of global rising heat, hastening climate change. Thermometer data from roughly 1850 provided global coverage, and temperatures skyrocketed after 1970 as a result of rising greenhouse gas emissions and sulfur pollution regulations. Surface temperatures have increased at a pace of approximately 32 degrees Fahrenheit every decade, with the 2013 to 2022 period averaging 34.07 degrees Fahrenheit over pre-industrial values. The ocean's heat absorption capacity caused land temperatures to climb nearly twice as fast as the world average, melting ice and snow cover have caused the northern hemisphere and Arctic to warm much more quickly. Future predictions indicate a 66% possibility of exceeding 34 degrees Fahrenheit warming between 2023 and 2027. The IPCC expects this average to be exceeded by the early 2030s. By 2100, temperatures might rise by 34 to 35 degrees Fahrenheit under a very low emissions scenario, 36 to 38 degrees Fahrenheit under an intermediate scenario, and 38 to 42 degrees Fahrenheit under a high emissions scenario. To keep global warming around 34 degrees Fahrenheit, fossil fuel consumption must be dramatically decreased. El Niño and La Niña are natural climate cycles that cause short-term temperature changes. These cycles, along with external forcings like greenhouse gas concentrations, solar luminosity, volcanic eruptions, and Earth's orbital variations, influence global temperatures. Human contributions to climate change can be identified by the different fingerprints of potential causes, such as greenhouse gases, which trap heat and warm the Earth's surface. Since the Industrial Revolution, fossil fuel use has significantly increased greenhouse gas concentrations, particularly carbon dioxide and methane. Greenhouse gases absorb and re-radiate heat, restricting its escape into space. Since 1750, human activities have increased carbon dioxide and methane levels by 48% and 160% respectively. Deforestation and other land surface changes contribute to global warming by releasing previously stored carbon dioxide. Aerosols typically cool the atmosphere by reflecting sunlight, but when black carbon settles on snow and ice, it heats the surface and enhances absorption. Solar and volcanic activity influence the climate, but they have had little effect on temperature fluctuations since the Industrial Revolution. Climate change feedbacks, such as water vapor and ice albedo, worsen the initial warming. Thawing permafrost and increased methane emissions from wetlands exacerbate climate change. Land and oceans absorb half of human-caused carbon dioxide emissions, but this proportion is declining as climate change disrupts the carbon cycle and feedback processes. Climate change has far-reaching environmental repercussions, including changes to the ocean's ice and weather patterns. Droughts, heat waves, and monsoonal precipitation have been more common since the 1950s. Sea levels are rising as a result of thermal expansion and melting ice, and considerable increases are projected by 2100. The Arctic is losing ice, and its waters are becoming more corrosive. Tipping points such as the irreversible melting of Greenland's ice sheet might have far-reaching implications. Climate change affects biodiversity by forcing species poleward, increasing the risk of extinction. More frequent marine heat waves and ocean acidification have similar effects on marine life. Climate change exacerbates human activity, causing food and water scarcity, health concerns, and economic losses. Vulnerable populations, particularly those in low-latitude and impoverished locations, face the greatest risks. Climate change is also causing inequality and migration as sea levels rise and extreme weather conditions worsen. Overall, climate change poses substantial and broad threats to natural and human systems, necessitating prompt mitigation and adaptation efforts. Climate change mitigation comprises lowering greenhouse gas emissions and increasing carbon dioxide removal. To limit warming below 34 degrees Fahrenheit, emissions must be eradicated by 2050. This necessitates significant changes in energy, land, cities, transportation, infrastructure, and industry. The Paris Agreement pledges must be tripled to keep warming to 35.6 degrees Fahrenheit, with far larger reductions for 34 degrees Fahrenheit. Renewable energy, particularly wind and solar, is crucial, as fossil fuel consumption is projected to peak by 2030. Renewable energy must dominate electricity generation, and transportation should shift to electric vehicles and low-carbon fuels. Important solutions include improving energy efficiency, lowering agricultural emissions, and increasing carbon absorption through reforestation and soil management. Carbon capture and storage and bioenergy with CCS may help achieve net negative emissions. Nevertheless, relying on these technologies is dangerous. Reducing energy demand and transitioning to renewable energy have both health and economic benefits. Adapting to climate change entails responding to existing or expected climate effects. Adaptability alone without mitigation cannot avoid serious repercussions. The ability to adapt varies, with developing countries generally having less capacity. Adaptation policies and practices include avoiding flood-prone areas, increasing flood management, and maybe relocating communities. Agriculture practices include sustainable diets, crop diversification, and erosion control. Ecosystem-based adaptations, such as restoring natural areas and increasing ecosystem connectivity, also aid human adaptation. There are synergies and trade-offs between adaptation and mitigation. For example, compact urban development minimizes emissions but may increase heat exposure. Mangrove planting, seawall construction, green roof installation, and drought-tolerant agricultural development are all practical adaptation possibilities. Economic restrictions and unequal access to resources and insurance are significant obstacles to effective adaptation. The countries most vulnerable to climate change have historically contributed little to global emissions, prompting concerns about justice and fairness. Limiting global warming is crucial to achieving the United Nations Sustainable Development Goals, which include eradicating poverty and reducing inequality, as stated in Goal 13, urgent action against climate change. The geopolitics of climate change are complex issues that are typically perceived as a free rider problem, despite the fact that localized benefits, such as improved public health from less coal consumption, can outweigh the cost. We can drastically reduce emissions and air pollution mortality by instituting carbon pricing, which accounts for around 20% of global emissions, and eliminating fossil fuel subsidies. Supporters of climate justice claim that those most responsible for emissions should bear the costs of adaptation, which will assist those most affected. Wealth disparities are extreme, with the top 10% responsible for half of emissions. International agreements like the UNFCCC Kyoto Protocol and Paris Agreement aim to stabilize greenhouse gases and help impoverished countries, while global emissions continue to rise. Recent initiatives, including the European Green Deal and pledges from South Korea, Japan, and China, aim to reach carbon neutrality by the middle of the century. Despite these efforts, existing national climate plans fall short of the reductions needed to keep temperatures below 34 or 35.6 degrees Fahrenheit, highlighting the critical need for greater action. The public debate on climate change has been heavily influenced by denial and misinformation, particularly from fossil fuel companies, industry groups, conservative think tanks, and contrarian scientists. These groups have used techniques similar to those used by the tobacco industry to cast doubt on scientific evidence in order to postpone legislative reforms. Climate change denial can take numerous forms, ranging from outright denial of warming to downplaying its negative repercussions. This has created a false perception of significant scientific uncertainty, delaying vital action. During the late 1980s and early 1990s, public knowledge of climate change rose dramatically. However, ignorance about other environmental challenges, such as ozone depletion, persisted. Movies like The Day After Tomorrow and Al Gore's An Inconvenient Truth contributed to raising awareness. Public concern varies by region, gender, age, and political affiliation, with more educated people, women, and youth considering climate change as a serious issue. Concern has grown over time, and many now consider it a global emergency, resulting in increasing support for climate policies. The climate movement consists of public demonstrations, divestments from fossil fuels, and lawsuits. Notable protests include the School Strike for Climate, led by young people, and civil disobedience acts by groups like the Extinction Rebellion. Litigation is increasingly being used to force governments and businesses to adopt more aggressive climate action and compensate for the damage caused by climate change. Scientists first recognized the potential consequences of climate change in the 19th century. In the 1820s, Joseph Fourier proposed the greenhouse effect, which explains how the Earth's atmosphere traps heat and causes the planet to warm. Eunice Newton-Foote demonstrated in 1856 that air containing carbon dioxide warms significantly, hinting that carbon dioxide might raise the Earth's temperature. In 1859, John Tyndall confirmed that gases like carbon dioxide and methane absorb heat and impact the weather. In 1896, Svante Arrhenius developed the first climate model, predicting that doubling carbon dioxide levels would boost temperatures by 41 to 42.8 degrees Fahrenheit. He He discovered that rising carbon dioxide levels will accelerate warming through a feedback loop involving water vapor. Despite initial skepticism, our understanding of carbon dioxide's effect on the climate has improved. Guy Stewart Callender offered evidence of rising carbon dioxide levels and global warming in 1938, but was treated with the same level of skepticism. By the 1950s, Gilbert Plass's thorough computer simulations, as well as Hans Suess and Roger Revell's research, revealed rising carbon dioxide levels and restricted ocean absorption. Charles Keeling's ongoing measurements, termed the Keeling curve, confirmed this trend. James Hansen's 1988 statement to Congress contributed to public awareness. The IPCC, established in 1988, solidified scientific consensus on human-caused climate change. By 2019, investigations revealed that more than 99% of climate experts agreed that human activity was to blame for global warming. The 2021 IPCC assessment report declared unequivocally that humans are to blame for climate change, prompting calls for global emission reductions and preventative measures. This was on the agenda for climate change. I made an effort to provide you with all the details. Please remember to leave your opinions regarding climate change below. See you in another video.